Every now and then, astronomy presents us with a moment that compels us to reconsider our understanding. A subtle signal, a delicate measurement, a faint shift in light, and suddenly, a new reality unfolds. This week, that moment arrived from Mars, a spacecraft, revolving around Mars and fitted with imaging instruments far more stable and isolated from sunlight shadows than our terrestrial platforms, has accomplished something remarkable. It has mapped the trajectory of 3I Atlas, our latest interstellar guest, with tenfold the precision previously achievable. To the general public, this might appear as a technical detail, but for those of us modeling interstellar dynamics and scrutinizing the intricate details of celestial movements, this is monumental. When you trace an object's path with such a level of precision, you are not merely forecasting its location. You are narrating its tale. You discover its origins, how various forces have influenced it, and whether it behaves like a natural object or something else. When that object is traversing our solar system from another star, every decimal point is crucial. This measurement, this gentle gift from an orbiting platform around Mars, reshapes our perspective on planetary defense, interstellar debris, and even the potential for technological artifacts adrift among the stars. It also offers us an unprecedented chance to examine an anomaly before it fades into the void. The trajectory acts like a biography. It reveals the one truth an object cannot disguise. Every known force in the universe, gravity, radiation, plasma, drag, outgassing, magnetic fields, leaves distinctive marks on a moving body. Most comets exhibit familiar signatures. They veer in predictable fashions because sunlight vaporizes ice from their surfaces, and the recoil from these jets gently nudges the comet off its gravitational course. However, 3I Atlas is not your typical comet. Before this measurement from Mars, its motion already hinted at non-gravitational acceleration that was inconsistent with the physics of a standard icy nucleus. Some of these deviations were subtle, too subtle for Earth-based telescopes that are affected by atmospheric distortions and the motion of our own planet. But from Mars, the geometry shifts, the parallax changes, and the observational noise diminishes significantly. Where Earth perceives a wobble, Mars detects a straight line. This line, this precise arc, etched in the Martian sky, indicates that 3I Atlas is under the influence of forces we have not yet fully comprehended. The most conservative explanation suggests unusual outgassing. Yet, the comet is outgassing at distances where ice should not sublime. The less conservative, yet scientifically plausible explanation is that we might be witnessing phenomena in physics that we haven't modeled before. In either scenario, this measurement is not just a minor update, it is a revelation. Science advances by addressing anomalies rather than overlooking them. The refined measurements from the Mars orbiter reveal a consistent directional acceleration that does not conform to the standard equations applied to natural comets. When graphed against time, the deviation exhibits a smoothness that astonishes me. Natural outgassing tends to be chaotic, fluctuating as patches of ice heat up unevenly. However, 3I Atlas displays a pattern more akin to a continuous force, suggesting that the source of acceleration is stable rather than sporadic. Could this be due to a deep reservoir of hypervolatiles venting in a consistent manner? Perhaps it is a result of unfamiliar interstellar materials whose thermal responses differ from anything observed in our vicinity. Or like Oumuamua before it, is it demonstrating behavior reminiscent of a lightweight, light sail-like object undergoing radiation pressure? We do not know. However, with 10 times greater positional accuracy, we can begin to eliminate the impossible and concentrate on the improbable. In astrophysics, improbability is frequently the cradle of new understanding. Planetary defense encompasses more than just stopping impacts. It is about grasping the cosmic environment that envelops us. For most of human history, we believed the most significant threats came from local asteroids, fragments from our solar system's formation. However, the emergence of 3 interstellar objects within less than a decade alters the landscape. If interstellar debris is more prevalent than we once thought, Earth's planetary defense models must evolve. Why? Because interstellar objects possess higher velocities, unpredictable chemical compositions, and non-gravitational forces that deviate from typical cometary trajectories, which can alter in ways we have yet to model. If even a single interstellar fragment, traveling at tens of kilometers per second, were on a collision course with Earth, the warning time would be considerably shorter. Thus, precise trajectory mapping is fundamental. The Mars orbiter's measurement is not merely an academic pursuit. It exemplifies a new architecture for global safety and a multi-layered observational framework. Earth perceives one angle while Mars provides another. Future missions around Venus or Jupiter could add even more perspectives. With 3 or more observation points throughout the solar system, we can triangulate interstellar objects with unprecedented accuracy months earlier than before. In other words, Mars has just offered us a glimpse into the future of planetary defense. Let me clarify. 3i Atlas is not on a collision course with Earth. The importance lies in what this measurement reveals to us. If I was speaking before a camera right now, I would express it this way. This new measurement from a spacecraft orbiting Mars uncovers something profound about our relationship with interstellar objects. It demonstrates that when we broaden our perspective beyond Earth, we attain clarity, not just in astronomy, but also in understanding our cosmic neighborhood. By mapping the trajectory of 3i Atlas with tenfold accuracy, we have taken our first step toward a solar system-wide early warning system. A network capable of detecting, tracking, and analyzing rapidly moving objects from other stars. This is not science fiction. It is a natural extension of how we safeguard our planet. The more precisely we monitor these visitors, the more insight we gain regarding their composition, origins, and the processes that shape them. Some may be natural, while others could be unusual. And in rare instances, a few might even challenge our notions of technology within the universe. Regardless of their nature, one thing is evident. The cosmos is far from silent. Objects from other stars pass through our solar system more frequently than we had imagined. If we proceed wisely, we should regard each one not as a threat, but as a message. A message from a distant system inscribed in ice, dust, and movement. The Mars measurement is merely the starting point. In the coming months, NASA and the ESA will refine their models. Ground-based observatories will seek to detect micrometeorites. Radar arrays will investigate metallic content, and the Galileo project, which I lead, will explore the potential for techno-signatures. Planetary defense networks will integrate new algorithms trained on interstellar behavior. This marks the dawn of something unprecedented, a moment where astronomy, planetary defense, and interstellar science intersect at a pivotal juncture. 3i Atlas may soon vanish into the void, and we might never observe it again. Yet its trajectory, that fine and precise arc, measured from Mars, will serve as a model for the future. A future where Earth, Mars, and perhaps, one day, the moons of Jupiter unite to monitor the skies not as isolated worlds, but as a multi-planetary civilization. Because that is the true significance of this. The Mars measurement transcends a mere scientific accomplishment. It embodies an act of cooperation across planets. A quiet, yet profound step toward humanity, transforming into a species that listens to the galaxy rather than merely existing within it. For me, that represents the utmost discovery. 3i Atlas is a visitor from another star. And thanks to a spacecraft orbiting Mars, we now grasp its trajectory with remarkable clarity. The universe has conveyed a message to us, and at long last, we are prepared to receive it.